Hello students, welcome again to another maths lesson at senior level. Okay, now during the last lesson we looked at how we are able to solve different aspects with regards to the last topic. I can't recall the last topic just now, okay, but for today I promise that we'll be moving on to a brand new topic. And the topic for today's lesson is vectors. So we'll be giving an introduction to vectors in today's lesson. Alright, if you're ready, let's begin. What is a vector? Alright, now I know for those of you who are science students, this is not a completely new topic to you. However, for the non-science students, you will be coming across vectors for the very first time. Now, don't worry, I will try and give a brief explanation and introduction, and then we'll see how we carry on with calculations involving vectors in maths. Alright, so what is a vector? Briefly, a vector is simply a quantity with both size and direction. And I'm going to show you shortly what I mean by that. Okay, now we want to see how we can distinguish between scalars and vectors, because quantities in general can be categorized into two, scalars and vectors. So let's see what we mean by a scalar quantity and a vector quantity, and what the distinction or the difference is between the two quantities. Now, a scalar quantity is simply any quantity that can be described by just a number or size, or sometimes, sorry about that, magnitude. Oh, magnitude. Now, of course, it's going to come up later on, okay? You can't see that. So, examples of scalar quantities are length. For example, the length of a desk is 5 meters. Just the size, just the magnitude. Mass. The mass of a table is 10 grams. Temperature. Your body temperature is 28 degrees Celsius. And then age. How old are you? You are 16 years old. So it's just a number. It's just a quantity, a size in particular, or a magnitude. And that's all. And that is enough information to describe a scalar quantity. Okay? However, a vector is a quantity that needs a direction as well for it to be complete, for it to make sense. So you need not just the size to describe a vector quantity, you also need the direction. Alright, and then I'm going to show you some examples here. So you have vectors have both magnitude, otherwise referred to as the size, and direction. So vectors are not complete without the direction. Okay? And here are some examples. Velocity is a good example of a vector quantity, and it's speed plus direction. Okay? And here's an example. For example, the wind velocity is 20 kilometers per hour east. Alright? So if you don't put the units, or I should say, if you don't put the direction, then this becomes speed, just speed, alright? But with the direction, that makes this velocity. And of course, a vector quantity. Next up, displacement. Displacement is distance plus direction. So, an example is displacement of Leeds from York is 25 miles west. West. So that's direction. Without this direction, this becomes just distance. Alright, so take note. That is the distinction between vectors and scalars. Scalars, they have just size, only magnitude. However, vectors have got magnitude and direction. So take note. So in other words, we can say that vectors are directed quantities. Vectors are quantities with direction. Alright? And that's very important. Okay, so what do vectors look like? Now, vectors can be represented as follows. You can use straight lines for the size and for the direction you need. Can anyone guess? Arrows, exactly. So you have a straight line to represent the size of the vector and the arrowhead for the direction. It's very important. Okay, so you have the size of the arrow using the length of the arrow, and then the arrowhead for the direction in which it is pointing. Okay, now we can also use column vectors. What do I mean by column vectors? Okay, you have a representation like that, a column, okay, with 2 rows. Now when you have this column with 3 and 1, what this simply means is the vector, okay, has got 3 units in the x direction and 1 unit in the y direction. Meaning, if you want to represent this vector and you start at the origin, you go 3 units along the x-axis and then 1 unit along the y-axis, and that gives the vector as shown. Alright, so there's the starting point of the vector, and that is where it ends. So the start and the ending point. And that is a vector. And like I said, the direction matters. So there you go. These are ways of representing a vector. When you have an arrow with the arrowhead showing the direction, or if you want to use a column representation where you have 2 columns, the first row, the number of the first row for the x direction, and the second row, the number of the second row for the y direction. Alright? So there we go for the representation of vectors. Now, again, given this vector, which of course shows you an arrow pointing from A to B, meaning you start at A and you stopping at B. Okay, now you have some common representation of vectors that we can use. Now, you can write this down as A, B, meaning you started from A and then going to B. So you write the letters A, B, capital letters, and then with an arrow at the top pointing from A to B, showing where you started from. You started at A and then ending at B, A to B. So this is one representation. Or you put the letter A in bold. Now, of course, when you're writing this down, that may be a little bit difficult to do. And that's why we use this. If you're typing, well, of course, you can make the letter bold, that's fine. But when you're writing down, you can either write this, or if you write the letter A, you put an underline, or what we call a tilde. So sometimes this is acceptable, and then sometimes we can also have that. And so, if you want to write down this vector AB, you can write it down as this, or if you want to write underline, you write A with the underline like that, okay? To represent that vector, start at A and then stopping at B. Alright, so these are the 2 common ways of representing vectors. Now let's see, how do we combine 2 or more vectors into 1? Okay, when you do that, we have what we call resultant vectors. Alright, so in this example where you have the vector A going in that direction and then the vector B going down that way. And you want to combine the two vectors to give the resultant. How do we do that? Watch. Okay, so the resultant is a single vector which is equivalent to a set of vectors. So when you're trying to combine two or more vectors into one, what you get is called the resultant of all the vectors. So here we have two vectors, A and B, pointing in the directions as shown, and you want to combine these two vectors into just one. See, watch what we do. So the resultant of adding A and B, okay, so you put the two together, meaning if you start from there, and there's A, at the end of A, you put the beginning of B, and it stops here, meaning you start in there, and you end in there. So the vector that will combine A and B together, we start there, and then end right there, like that. And let's call that vector C. Alright, and so if you want to write this down in vector notation, the vector C is the vector A plus the vector B. Remember, the direction of the arrows matters. The direction of the arrows really, really matters. So you're going from you're going from that point where A starts to that point where B stops. The starting point and the ending point. And that is your C. So C, to get to C, or to draw C, you have to go from there to there, which is your A plus B. We'll see some more of this later on. Okay? Now here's number one. But I want you to observe this time, the B, although it's pointing down, has got a negative. So again, you want to combine the vector A and then the vector minus B to have the resultant, or to have just one vector. Let's see what you will have. So when you bring the two vectors together, and the idea or the rule when you're combining vectors is this. If you're starting, the starting point and the ending point of one, and then the ending point of one will be the beginning of the other. And then that also terminates somewhere where the arrowhead ends. Okay, so when you bring the two vectors together, so there you go, there's a vector A, there's a vector minus B this time, take note, minus B. Alright, so when you combine the two vectors into one, that's what you have. Again, let's call that vector C. So C, this time, remember, C goes from here to here, which in other words, it's like going from there to there, and then from there to there. Mind the direction of the arrows. Mind the direction of the arrows. Okay? So C, the vector C is the same as the vector A combined with the vector minus B. So C will now be equal to, can anyone guess? Exactly, A minus B. The vector C is a combination of the vector A and the vector minus B. So that is how we add or combine vectors to get the resultants. Okay, so when you combine two or more vectors into one, that one vector is what we call the resultant of the vectors we've combined. Alright, let's see some more interesting examples, because it's really important for you to be able to understand this, especially with the direction, before we go into the calculation of vectors proper. How we add vectors, how we subtract vectors, how we multiply vectors. So it's really important for you to know or take note of these basics or the foundation, and in particular with regards to the direction when you're combining vectors to find the resultant. Okay? So next up, let's look at some more properties. Let's look at some more properties of vectors. Now, vectors with the same magnitude and direction are equal. So if you have the same vectors as shown with the two arrows pointing in the same direction, okay, they are said to be equal. They're pointing in the same direction. They've got the same size. Same size, meaning the same magnitude, and pointing in the same direction. So the two vectors are said to be equal. Okay? So for example, if you've got the vector A, which of course points from A to B as shown. If vectors have the same magnitude and opposite directions, then, so if you have A, B, having the vector notation A, now BA will be pointing in the opposite direction. It's still the same size, it's still the same magnitude, but now it's pointing in the opposite direction. So AB is your A, then BA. Now remember, BA will point in the opposite direction. Okay, although it's the same size, but because it's pointing in the opposite direction, now it will be minus A. Okay, and that's why you've got BA there is minus A. Okay, so take note. Let's see some more examples. Now, if different sized vectors have the same direction, they are scalar multiples of each other. So we have these two vectors here. One is longer than the other, but you can see they're both pointing in the same direction. So you have one will be a scalar multiple of the other. So let's take the longer arrow to be the vector m and the shorter one to be the vector n. So, well, if you look closely, you realize that you can get two of this in that. So we can actually write the vector m as a scalar multiple of the vector n. And so m will be twice as long as n. So we can write that the vector n is twice as long as the vector n. They're both pointing in the same direction, as you can see, but one is twice as long as the other. Alright, which is what we've denoted here. And the vector n is equal to 2n. Alright? Now, resultant vectors can be broken down into their component vectors. What do I mean? You saw that earlier on. If you've got A, the vector A, the x component and the y component, what it means is the vector A is x units along the x direction, or along the x axis, and then y units along the y axis. Alright? So there's a vector A. Vector A, x units along the x axis, and then y units along the y axis. So you can also write down the vector giving the components, the value in the x direction and then the value in the y direction. We'll see some more of this a little bit shortly. So vectors can be rewritten in terms of other vectors as well. So if you have the vector A pointing as shown, and then the vector B pointing as shown, and you want to combine the two vectors. So the vector C will be A plus B, as you can see. So A plus B gives you the vector C. Now, I want you to rewrite the following vectors in terms of A, B, and C. Now, look at that. I want to find the vector BA, CB, DC, AC, and AD. And then, clearly to avoid any confusion, I've put arrows on each of those vectors to show you where you're going to be starting from and where you're going to be ending. Alright? Now, you are going to be using the vectors A, B, and C. And the vector A goes from A to B. The vector B goes from B to C, as you can see. And the vector C goes from C to D. So be mindful of the arrows. Use the arrows as a guide. So let's see the vector BA. The vector BA is in the opposite direction. Vector BA is in the opposite direction as AB. Therefore, BA will be what? Can anyone guess? Yes, minus A. Exactly, minus A. Next up, well, if you didn't quite get that, let's see the next example. What of the vector CB? The vector CB goes in the opposite direction as the vector BC. Therefore, the vector CB will be, can you guess, minus B. Exactly, because it's pointing in the opposite direction. CB minus B. Okay, so far so good. That's the next one. How about the vector DC? Vector DC, now look at DC. Again, DC is pointing in the opposite direction as a vector CD. And so, the vector DC will be minus, can you guess? Yes, minus C. Okay? Right, how about the vector AC? The vector AC. Now, look at the vector AC. To go from A to C, you have to go from A to B, B to C. So the vector AC will be the resultant of AB and BC. So the vector AC will be A plus B. That's right. So the vector AC will be A plus B. Okay? Next up, you have the vector AD. Aha! Now look at the vector AD. The vector AD, to go from A all the way to D, you have to go from A to B, B to C, and C to D. So the vector AD will be what? Can you guess? A plus B plus C. Exactly. A plus B plus C. And that's it. Alright, now if you got that, I'm going to give you some more interesting and slightly tricky examples. Again, you're going to have to rewrite the following vectors in terms of A, B, and C. Now, there's your A, there's your B, and there's your C. So let's start. E, D. The vector E, D. Aha! Now look at E, D. E, D is pointing in the same direction and also has the same size as AB. And so the vector ED is, can you guess? Yes, that's right. It is equal to A. Exactly. It's exactly the same as that. Moving on. How about the vector FE? Look at the vector FE. The vector FE has got the same direction and the same size as the vector BC. Can you all see that? The vector FE, going from F to E. FE, exactly the same as the vector BC, which is B. Exactly, so the vector FE is B. Moving on, how about the vector AF? The vector AF, look at AF. AF has got the same size and direction as the vector CD, and that is C. Okay, moving on. How about the vector AE? I want you to please try these examples, alright, before I show the answers. So you can actually pause the video and then give yourself that quick test. Test your skill and test your level of understanding. Okay, before you actually continue playing the video to see if your answers are going to be exactly the same as mine. Alright, it's very, very important just for you to be absolutely sure that you understand. Okay, so moving on quickly. AE. AE. Look at AE. AE. AE is the same as AF plus FE. AF. AF plus FE. So it's going to be B plus C. Okay, there you go. How about DA? DA. Right, now DA. DA is same as going from D to C, C to B, and then B to A. You're going in the opposite direction. So be mindful of that. Whenever you're going in the opposite direction, that will change the sign to negative. So take note. So going from D to A is the same as going from D to C, C to B, and then B to A. So DA will be, can you guess, minus C, minus B, minus A. Exactly. Minus C, minus B, and minus A. How about BF? So quick let's move on to BF. Look at BF. BF will be B to A, and then A to F. Now, B to A will be the exact opposite of AB. So it's going to be minus A plus AF. Now, AF, like I said, remember, is the same as CD. So it's going to be minus A plus C. Exactly. Minus A plus C. There you go. How about EC? Now, let's see. Let's draw an arrow. Let's do EC. EC is going from ED to DC. ED is the same as AB. So it's going to be A. Now, DC is the exact opposite of CD. So you have A minus C. Exactly. A minus C. And last but not least, DF. DF is going that way. DF is going that way. So it's DE plus EF. Now, DE is exactly the same as BA. You go in the opposite direction. So it's going to be minus A. Now, EF is the same as CB. So it's going to be negative there and negative there as well. So it's going to be minus A minus B. Minus A minus B. There you go. Alright? Now, let's see some more interesting examples. And like I said, I want you to pause the video and give yourself that challenge. See if you can rewrite the following vectors. There's these vectors in terms of A and B. Look at A. Look at B. A is half of that length, and then B is also half of that length. And of course, clearly here too, from P to N, it's going to be half of the length from P to Q. So be mindful of all of this. So let's see if we can rewrite all these vectors in terms of just A and B. AP. Let's start AP. AP is what? Look at AP. AP is exactly the same as OA. So that is A. How about AB? AB, aha. To go from A to B, now let me just show it up an arrow so you see clearly. So AB, to go from A to B, would be the same as going from A to O and then O to B. Now if you're going from A to O, you're going in the opposite direction. So that's going to make that negative and then O to B. So it's going to be minus A plus B. Exactly. Minus A plus B. How about OQ? OQ, aha, OQ goes from O all the way to Q. I remember from O to B is half of that. So O to Q will be twice OB. So it's going to be 2B. Exactly, 2B. How about PO? PO, we're going in the opposite direction. Going in the opposite direction. So that's minus 2A. What of PQ? PQ, look at PQ. PQ will be PO plus OQ. PQ plus OQ. PQ, well, we don't have PQ is what we're looking for. It's going to be PO plus OQ. PO plus OQ. PO plus OQ. So it's going to be minus 2A plus 2B. Minus 2A plus 2B. What of PN? PN is half of PQ. So just divide that by 2 to get PN. Because PN is half of PQ. So when you divide all that by 2, divide that by 2, and divide that by 2, so you will end up getting minus A plus B. Minus A plus B. Okay. Next up, ON. 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 I'm going to show that with an arrow to see clearly. So that's ON. ON. ON is OP plus PN. Look at OP. Well, OP is twice the length of OA. So you have 2A plus PN. Look at PN. PN is this. So this is what you end up getting. But I'm going to show you how we arrived at that. ON is OP and OP is 2A plus PN. Look at PN. PN is minus A plus B. Now 2A minus A gives you A plus B. Okay, and then AN. Look at AN from there to there. Right, now AN, as you can see, AN will be AP plus PN. So you have AP, now remember AP is exactly the same as OA. So you have A plus PN. Now remember PN is A minus A plus B. And when you do that, this is what you get. Now AP is going to be A, so you have A plus PN. PN is minus A plus B. Okay, and so that cancels, and then you're left with P. Left with P. B rather, I should say. So B is the value of the vector AN. Alright, I hope you all are following. I know it can be a little bit tricky, but trust me, it's not really hard to follow. Once you get the direction right, the direction is what matters most. You need to get the direction right. Moving on to BP now. BP, now let's see, let's draw the arrow from B to P. So there you go, that's BP. So to go from B to P, it's the same as going from B to O, and then O all the way to P. And that's quite straightforward. I'm sure you can see that. It's going to be minus B plus 2A, exactly. So minus B plus 2A. Now it doesn't matter which comes first, but ideally you might want to put the positive vector first. So minus B plus 2A, it's the same thing. This is still the same thing as minus B plus 2A. So don't worry. And next up, what about QA? The last up item is the list. QA is the same as going from Q to O and then O to A. And remember, if you go in the opposite direction, it's going to be minus 2B plus A. Exactly, minus 2B plus A. So again, you can see the vector of the positive comes first, but it doesn't matter. This is also the same as minus 2B plus A. Alright, so that is how we represent vectors using any vectors we are given. Correct, like I said, it's the direction that you really need to take into consideration. It's the direction that matters the most. Alright, let's move on. Now, let's see how we add vectors if we're given the components. Look at the vector A. It's got the components 4 and 5, meaning the x component is 4 and the y component is 5. And then the vector B has got the components 3 and minus 2, meaning the x component is 3 and then the y component is minus 2. And then we want to find the vector AC. Again, mind the arrows. Mind the direction of the arrows. The vector AC, that is you going from A and then end at C, is the same as going from A to B and then from B to C. Now A to B is this, and then B to C is that. So what do? Just add the two, like that. If AC, which you see, is A plus B, then the component of A is 4, 5, plus the component of B, which is 3 minus 2. And when you add the two together, 4 plus 3, and then 5 minus 2. So you have 7 and 3. Okay? Well, I hope you all can see that. So the vector C has got the components 7 and 3, meaning 7 in the x-axis and then 3 in the y-axis. So this will be, this is C, 7 units in the x-axis and 3 units in the y-axis. Okay, that's just a sketch. Okay, you don't have to take that too seriously. Next up, here's an example. Now, be mindful of the arrows here. B is now pointed in that direction, so take note. So the vector C, of course, you go from A to C, will be from A to B and then B to C, which is going to be in that direction, minus, take note. So you have AC will be A minus B, okay? Because as you can see, if you go like that, to get to C, you're going in the opposite direction as the vector B. So that's why it's negative there. You're going in the opposite direction. So that's where the negative comes in. there's a component for A, and there's a component for B, but with the minus because we're going in the opposite direction. B is going that way, but to get to C, we have to come down. That's why it's negative. So when you take that into consideration, 7 minus 4, 5 minus 3, and then when you do that, minus half minus gives you plus, 7 plus 4 gives you 11, 5 minus 3 gives you 2. And so vector C this time has a components 11 and 2, meaning you have 11 along the x-axis and then 2 along the y-axis, and so that would be the vector C. Not forgetting the arrows, please. Okay, so moving on. Now here's an example, an interesting example where this time you have to really take into consideration all the different vectors and their components. You want to find the vector AC, FB, FC, BD, and AE, and then to avoid any confusion, I've actually put arrows to show you where you're going to start from and where you're going to end. So take note of that. Now all the vectors you're going to need, the components have been given. All right. So now AC. Let's see. AC. You're going from A all the way to C. To go from A to C, you have to go from A to B and then B to C. So you add this and that. Or if you like, you want to take the longer route. This, and that. But that's going to be longer. Always take the shortcut. Okay, so AC will be 4, 4 plus minus 5 and 3. That gives you minus 1 and 7. And then FB will be FA plus AB. Like that. So you have 10, 5. FC now. FC will be FA, AB, and then BC. 6, 1, 4, 4, and then minus 5 and 3. And then BD will be BC plus CD. Now that's going to be negative. If you're going that way, it's going to be negative because of that. Okay, so that's where the negative comes in. Minus 5, 3, and then minus 4, 2. And then finally, AE, look at AE. There's AE, you're going in the opposite direction, so that's why this is minus 6, minus 1, and then plus that, minus 2 and 3. And that's what you get, alright? Well, I hope you all got that right, okay? Next up, now, like I said, when you have a vector, and you've got components given us that. That is a component in the x-axis, and this component in the y-axis. And when you combine the two to get x, you simply use the Pythagoras theorem. Remember the Pythagoras theorem? The square of the longest side is always equal to the sum of the square of the two other sides. So the longest side here is x. So the square of x is equal to the sum of the square of the two other sides. 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. Now 9 plus 16 gives you 25. Now if x squared is equal to 25, therefore x will be the square root of 25. And that gives you 5. Now this is what we call the magnitude or the modulus. So if you're asked to find the magnitude or the modulus of any vector, this is what you do by simply finding or using Pythagoras to find the unknown side. Alright, now to wrap up this class, I would like to give you as an assignment finding the magnitude of these 3 vectors where you have 5, 12, 8, 15, and then 24, 7. So all I need you to do using the previous example, find the modulus of each of these and then send your answers to my inbox. Alright, that brings us to the end of today's lesson. Next we'll continue looking at some more examples of vectors and then go into more detail. Alright, at this point I'd like to stop and then I'll see you next lesson. Goodbye and stay safe.